Thank you very much for this kind introduction and for the invitation to this event to Bilbao. It's actually my second time in Bilbao, and I really like the city. Yeah, today I will talk about our recent work on explanation, but I will bring you kind of to this by also reviewing and discussing some of the methods, some of the foundational methods which we developed to get there. So if we kind of build human engineered systems like airplanes, engineers know the quality, know the functional role, know the properties of every component. So I recently read that in an Airbus, I think there are like 3 or 4 million components. So it's this kind of every screw in the airplane needs to fulfill certain quality requirements, has a specific function, can be simulated independently, and of course, in the end, the whole system needs to be tested and validated together. Our AI models are even more complex, although many of them have less components, but much more parameters. So the components are interconnected in a very complicated manner. And these models, like large language models, are optimized in a holistic fashion. So based on data, we take data and we train these models, but we don't really know the functional role, the quality of individual components, for instance, of individual neurons. And there is not much work on validating individual components, validating the decision-making properties of today's models. And this is kind of what my talk is about. So we are developing methods which allow us to get deep insights into the functioning of deep models, and this can help to get you some insight about the functional role of every element of the system. So basically, what we asked ourselves a couple of years ago when we kind of worked on a project for skin cancer detection is whether the models which we kind of train follow the same rules as dermatologists. So if you went to a dermatologist, you probably know that there is this ABCDE rule. So if a navy is asymmetric or has kind of blurry borders or like uneven